Hello everyone, and thank you for joining us today. I'm Daniel Chilcott, Managing Director at Flowgear, and with me is Ricard Skostro, one of our software engineers. Today we're going to be talking to you about Flowgear web apps. Very excited to be able to present some of the changes that we've been making here. So before we get into the content, I want to give some context around where these web apps fit in. And really the essence of the issue that we're trying to solve here is that no single app in a business of any reasonable size is going to fully capture a way of working, a way of dealing with the process. And so what that means is necessarily an individual member in the team is going to work across multiple apps to be able to fulfill a request. Now, if you're already a Flowgear customer, then hopefully you're already using Flowgear workflows to automate processes end to end. But there are a lot of processes that require a human in a loop. There's some discretionary part. Maybe there's a time lag between when you perform step one and perform step two. So what Flowgear Apps allows you to do is it creates a front end that bridges multiple underlying apps, and that then allows you to enable a process in your business that is expressed the way the business sees that process, not the way that it's prescribed by any individual app or service. So what we want to look at is just the categories of use cases for Flowgear Apps. Then we'll look at some very quick examples of some of those categories. So fundamentally, these are kind of the main 5 categories that we see our customers using Flowgear Apps for. The first, as I've alluded to already, is this idea of needing to stitch together functions from multiple underlying apps. So perhaps you're running an e-commerce store and you've got an ERP, and perhaps most of the time you are synchronizing those orders from the e-com platform into the ERP, but there are other products that you need to get into as well. You can use a Flowgear app to consolidate that down to a single process. So if there's any discretionary element, perhaps the choice of the shipping or how you're going to allocate stock from the warehouse, any element that requires a human in the loop, you can consolidate those functions down using a single Flowgear app so that the user doesn't have to go into multiple of the internal or backing apps. Another common case is just reducing the number of clicks, or in other words, the number of interactions that someone needs to take in a business app to get a task done. And typically what you'll see is if you are using an ERP and there's a particular way that, for example, a sales order gets created, that UI has to cater for every way that a sales order could be created. Even if it's being configured specifically for your business, there are still going to be steps that need to be performed manually that wouldn't need to be there if it was built specifically for you. So another case for a Flowgear app is that you can remove those automated or those kind of rote steps. You can condense them down into the fewest possible number of clicks. For example, you might want a way to generate a proposal that's good for 80 or 90% of the proposals that you're putting out there. Maybe it's a basic structure. These proposals always select from one of a very small number of products. And so you can build a proposal creation function that just takes a few clicks and a few data points to be captured. And if that can deal with 80 or 90% of the cases that you need to get proposals out, it's a much nicer way for your team to work. And they can fall back to the full process in the ERP or the CRM when they need to. Another very common use case is you'll typically find that you have licensed a piece of software for all users in your company, even though many of the users only require it for 1 or 2 use cases. So you can sometimes have very significant license savings by looking at those kind of edge case use cases that are causing you to have to license those teams, build that in an app instead, and then save on the licenses. Imports and exports we've grouped together, but they're actually quite different. A lot of products allow you to do some kind of bulk import, for example. Maybe ERP is a great example here, bulk importing inventory when there's a pricing change, or maybe multiple orders from customers, for example. But usually you have to present the data in the form that is prescribed by that product, by the ERP. So what an app can allow you to do is ingest the data directly in its existing form. So maybe it arrives as a CSV document sent from a customer. You could just build an app that allows you to ingest that all the way through to a customer order without having to manipulate the form of that data. In the reverse direction, sometimes the user interface of a product doesn't allow you to export lists of things. So using the product's API, you can get that list, and using an app, you can have a convenient front end that empowers more people in your organization to be able to pull those lists. And then finally, the dashboard use case. There's kind of 2 scenarios here. One is that you can use Flowgear, create a bunch of workflows that sync data into a warehouse, and then the dashboard is basically live queries on that data warehouse. And the second scenario is if the different data sources are fairly responsive, they return results quite quickly, then the dashboard could actually make live calls to those underlying sources and you can get real-time data. And that's good for cases where you need sort of highly tailored information to be available to specific business units. So with those kind of categories in mind, I'll just pick a few of the practical examples out of that. Top right there is a good example, correct failing sync data. You might have built an automated integration. Most of the time, for example, the orders sync from your e-com platform to ERP, but from time to time there's a holdup. Maybe the customer is on a credit hold, maybe the inventory item has been disabled because you're busy replacing it out with a newer version of the product. Many reasons that a small percentage of orders might fail to sync automatically. So you can build a remediation app that allows you to correct data on the fly. This is very useful where you're not able to correct it at source. Perhaps in the e-com product, the order is already considered to be locked in. You're not able to edit it there, and yet you need to reflect the order in a reasonable state in the ERP. So you need to be able to change the data on the fly, and then having corrected that data, cause the integration to re-trigger. I mentioned the proposal creation example earlier. Again, an example where most of your sales team, most of the time, probably need to build very similar types of proposals. You could use an app to make that much easier. What about something like a fast inventory lookup? So instead of having to sign into the ERP, navigate to the right screen, you could kind of, from one click after signing into Flowgear, get straight to an inventory lookup, see what stock's available, and perhaps some custom buttons around that to reach out to someone who's responsible for the warehouse to make an inquiry around a product, for example, or look at whether there are POs open for a particular inventory item and what the expected date is that you're going to receive stock on that item. Let's look at one other example. Perhaps you have a ticket system where your customers are able to log tickets, but what about allowing your internal team to be able to log tickets as well? Perhaps you don't want your entire internal team to have a license for your internal ticket system, so you can instead create a simple app that allows them to log tickets and then see a status of tickets that they created in the first place. So we talked about some of the use cases that Flowgear apps are typically used for. Let's now look at the functionality that we're giving you as part of Flowgear apps. What does that actually mean? So first thing is that you're going to get a starter template that works out the box. What this means is a bunch of code that's going to fire up with almost zero changes and create a hello world app that you can begin to work on immediately. So we've taken all the decisions around all of the different JavaScript libraries, and we can get into that, and certainly we'd be happy to work with you as you start to unpack these things. But we've made decisions around that. We've set it all up for you. The styling just works out the box. Then fundamentally, the apps that you create in Flowgear are front-end only. And this is important for a few reasons. One is that if you had to create a full stack app, so you had to create the middle layer that deals with business logic and the data layer, which is the source of that data, this gets much more complex to build, it's much bigger to build, and there are a lot of potential foot guns in terms of security. How are you ensuring that the access to these is controlled correctly? So Flowgear apps are front-end only. That means you can build them very quickly. And Flowgear itself, the Flowgear workflows that you build, act as your business logic layer, and ultimately your internal business apps, your ERP, CRM, HR system, and so on. Those are your data layers. So if you think of apps as a kind of a three-layer system, you're just focusing on the front end, which means you can work really quickly. Third thing we add is that we handle the hosting for you. So there's kind of one place to go. Users are going to sign into their Flowgear console at app.flowgear.net. They'll have a choice of apps available to them, and they launch immediately there. Everything that you need is deployed there. The availability is taken care of, and the backing workflows that are used to send and receive that data is the Flowgear tenant itself. Tied in with that, because users are signed into the Flowgear console, we also understand the security context that they're operating in. So not only do we know which site they have access to in your tenant and which gross kind of coarse security group assignment they have, but you can also control exactly which workflows sets of users are able to interact with. So you can kind of fine-grained control exactly which workflows users are going to be able to interact with through the apps that you've published. And then finally, you can just build and debug in your favorite IDE. And what that will actually do is allow you to build locally, and when you run it, it's actually going to embed the debugged version of your app into the live console. So you can see exactly what the experience would look like for an end user once it's been published. So that gives you hopefully a sense of what is involved in these apps. Now let's talk about vibe coding specifically. So we gave some introduction to this idea if you haven't already come across it, but it's basically taking an AI assistant and running it on a loop, which means that you can prompt an assistant to write some code for you. It can hammer out those changes progressively. It can compile, it can figure out issues and correct them and so on. So even if you don't have front-end experience, even if you don't have software development experience, it's surprising how sophisticated the apps are that you can build just by prompting. And I'm going to show you some examples of that today. As I mentioned earlier, the workflows in Flowgear are going to be the back end of your app. So you're going to start with that. You're going to build the workflows that are used to send and receive data to and from the app. Then you're going to clone our starter project. It's a public GitHub repository. So that's your starting point. You bring that local. Then based on the workflows that you created, you're going to export definitions out of Flowgear. We use a standard called Open API, which is a way to describe APIs. So any workflow that you've built in Flowgear and published as an API will be included in that Open API definition. You bring that definition into your project, so it's part of your source code. That is the information that the AI agent needs to know how to create these interactions. And so then you move on to prompting the agent to help you get this built out. You wait a few minutes, see the results, and you can test locally with the agent embedding that, or with the IDE embedding your app directly into the Flowgear console. Right, so from here, we're going to get into a demo. We've got 4 things that we're going to deal with today. First, we're going to look at a two-way bind to a database, so getting a list of contents from a database displayed in an app. Then we're going to make that editable and allow you to actually write changes back. Then we've got a lead dashboard, do some interactivity around that. Service ticket triage, where you can change some information around service tickets. And then finally, an example of the use case that I spoke about a little earlier, where you can correct data that has failed in flight so that it can be reprocessed. With that, I'm going to hand over to Ricard, who will walk us through the demo.
Okay, thank you, Daniel. Yeah, so we're going to get right into it. So first, I'm just going to start in the Flowgear console. So to clone the starter template that Daniel mentioned, you just need to navigate into Flowgear, you go into your settings page, and then go navigate down to manage apps. So in here, there'll be a link to clone a sample application. So we'll just click on that. So this will take you through to GitHub, where our starter template is located. This is a public repository, so it's available for any user to be able to clone. Now, once you're here, you will get your URL and clone it into locally, so you can actually work on that. So I have done that, so I'll switch on that. Next, what you'll do is go into the API key, so we'll touch on this a bit later. But for now, I just need to download the Open API definition. So this is, as Daniel mentioned, the definition for the specific workflows we are going to use as our backing for the web app. So just going to download the Open API definition here. I actually also have this stored, so this is just where it will be stored. So in your application that you have created, there is a file called Open API YAML, so you'll just save it right there. I'm not going to do that currently. Then we're going to move on to our already cloned sample application. So this is the application opened up in VS Code. So just going to start off with a very basic npm install. So what this will do is actually install the packages as defined by our package JSON, which is the packages that the web application needs. So once that's installed, we are going to then just run it. So we're going to run the command npm run dev. What this will do is automatically open up the sample application. I'll also just give you a hint now how to enable it so it will correctly go to your tenant and site specific to you.
So this is really important because you won't be able to really build the app unless you're actually signed into the console. So yeah, it's kind of a harness that allows it to drop directly into your live console, so it knows which tenant you're in, which site you're in, which user you're logged in as, and then it can validate the permissions for the workflows that you need to run.
Cool. Exactly. So here we have our hello world. It's actually currently debugged and accessible via our console. So just going to go back to our sample application here. So just going to quickly discuss a few points here. So as mentioned, this is our env.local file. So These specific properties are used to open up the console when you're debugging, so it embeds it in the correct tenant as well as the site. And yeah, what else we also can discuss here is we have this file called the agents.md. So this is specific to Codex, to the vibe coding, as this will just provide more context to the AI model to know how to invoke our SDK, as well as certain rules that you would like to include, some coding practices. It can be extended as need. This is currently a very basic setup to ensure that it calls, for example, our OpenAPI YAML definition to discover available endpoints, which I'll touch on in a bit, but I can quickly just copy that over. So this is the previously downloaded OpenAPI definition that you saw we downloaded from our API key page. So I'm just going to paste it in here. I'll quickly do a run over. This is basically a list of available APIs via that API key that is connected to the specific workflows we provided. So this is all the use cases we're going to run through today. As you can see, we have some paths here, so getting some ConnectWise tickets. We have different methods and different bindings, as well as different schemas. This will be used by the context to know how to actually invoke and correctly construct these APIs and to consume the specific data.
Just to reiterate, you're not building any of this by hand. You're creating a bunch of workflows, and when you export the definitions you get in this, you don't need to be able to parse it. You just take that file and put it straight into your repository.
Cool. Yeah, so our first use case, we're just going to do a basic CRUD operation. So we're going to retrieve some context from a SQL database, and we're going to also, in the next iteration, make those fields editable. So I'm just going here into my Codex extension. So this is a VS Code extension. You do need an active subscription for this. Once you have that installed and connected, you can just set your settings to work locally. You can have a mode. Currently, I'm setting it to agent full access. We have the model using 5.1 Codex Max. And then we also have a high reasoning for better accuracy. So it will think a bit longer, but you'll probably get some better results. So as that is now going along, it's actually running through commands and updating our code base. I'm just going to go through a couple of things in our console. So the first thing I want to touch on is the API key. So this is we have different types of API key. This is specifically a cookie-based API key designed for our web apps. How this works is it's based on the user context actually debugging and signed in when accessing the application. So there's no extra token or anything you need to add. It's all handled automatically. What you can also see here, we have a target environment specified. So this is just also for finer access control. So you can target a specific environment at a time. We have a list of permitted users. As you can see, we are currently the only users that are allowed. So if another user will attempt to run this app, they will not be able to invoke these workflows. Then we have a list as well of assigned workflows, which is the fine-grained access that you need. So these workflows are the ones we're going to show in the webinar today. So any other workflows we won't be able to access.
I think also important to mention that for users who don't really do anything else in Flowgear, if the only reason that they're going to use it is to be able to launch an app, then when you add them into your site, you don't need to give them any security group. You leave that blank, and their access is going to be controlled entirely through based on the workflows that you've assigned in API keys for that user, as you see here.
Correct. And then another thing, so the OpenAPI definition that you download from here is also only scoped to the workflows that you assign here. This is also important because you don't necessarily want to allow or access all OpenAPI definitions and put that in your code repo when it's not needed, since Codex can also then use that to try and invoke different endpoints that you might not want.
So our recommendation would be that you create an API key for each app that you're building. You might find that some apps share the same workflow. That's fine. You can specify the same workflow across multiple keys, but it means that as you're building a specific app, it's only seeing the workflows that are going to be relevant for it. And one reason that we've added this OpenAPI export is as you're going through building the app, you might realize that you need to change a workflow or add a new workflow. So the idea is that you can go and do that, go back to the key, re-export, get the new file, just place it straight in, and then the agent's going to be able to take advantage of that very quickly. So it's just supporting you through the iterations that you're likely to need between back-end changes, workflow changes, and front-end.
Okay, cool. Now that we're back here, we can see it's finished with the first prompt. So as you can see, it added a typed contact model. It invoked the endpoint that we asked by providing the workflow in the prompt. It also updated the app to actually load some contacts through Flowgear, adding some loading and error states. So it also usually runs an npm run build just to confirm that it can compile and that it is successful. Otherwise, it will reiterate and fix the problem. So now we can just go back here to the debugged app, and now we can see Hello World has disappeared and we have a list of contacts. So for a follow-up on this, we're going to just ask it to go and make it editable, because we don't just want a list, we actually want to edit some fields. So just going to ask, make the table editable, add a submit button that sends the updated data to the SQL update contact workflow. Now it's going to go ahead and think a bit and run through a couple commands. So while we do that, we can go back and check on the workflows. So these workflows are now the backing workflows that the API definition has been downloaded for. So we have two in this case. We have our get contacts that just been used to actually retrieve that list or that table of contacts. So these are just very basic examples. This is, for example, a SQL query that just goes and retrieves a few contacts. Then we take that and convert it to JSON, as that's what we want to consume in our application. We then just provide it as the response body for the API binding. As we can see, we also have a sample here. This is for the OpenAPI definition, so it can understand and construct a schema, so it better knows how to consume the result that we are going to pass back. What else we also have in API bound workflows is that we set the HTTP binding. So this would include the binding method as well as the binding path. This is also what has been noted in the OpenAPI definition YAML, and this is how this endpoint would be accessible. Okay, let's just quickly see how it's doing. So it's cracking along. We have some more services that it's adding. It's updating our main application, and now it's actually reviewing some responsiveness. Okay, looks like it completed there. So it added some more models and also added some editable table or editable inputs in line, as well as added a toolbar submit changes button that will actually now go and update the table in SQL. So let's go see what it looks like. You can see now these are editable, which it wasn't before. So we can just make any type of change. We're going to go and submit that. See, it even added some loading states without needing to ask. And now I can just do a refresh to confirm. Yes, and after that refresh, we see the change has been committed, has been received. And yes, that's the first sample or first use case complete. So it's just a very basic update the table contact, retrieve contacts. But as you can see, it was very quick to do. And also one thing you can now do is iterate on the design. You can iterate on what functionality you want just by asking or prompting a few more times as you see fit. So on that, I'm going to go to our next use case. I'm just going to open up GitHub. So yeah, GitHub is version control. So it's just how you actually manage. That's how you also clone the actual sample. So just going to switch that, leave my changes there. Okay, now if I switch back here, you'll see we're back on Hello World. So for our next use case, we're going to look at a Salesforce lead management dashboard. So we're going to start off by just creating a card layout. Let's quickly get in there. I'm going to open up a new chat here. It's going to create a card-based layout showing sales leads with company name, contact, lead source, and status badge by calling the Salesforce Get Leads workflow. So this will now go ahead and do the similar thing, go and think and run a couple commands to actually go and build this. We can quickly see here in the actual OpenAPI definition what is going to be expected. Here we have our Salesforce leads, so we have a patch option, and we also have get. So this will actually go and retrieve the leads directly from Salesforce. We also have our schema that basically has a object and an array of records, which each has a type properties. We have ID, we have name, first name. This is all directly returned from the Flowgear workflow. I guess we can quickly go and look at that workflow while it's still busy thinking. So we have our Salesforce lead management in our get leads workflow. So we can see here we have a Salesforce node, we have an action on query, and we're querying the lead object. We have a basic request just returning the list of items from the lead object. We then have our quick map, so we only want to return specific fields. We don't necessarily always want to return the entire response, because some systems have quite large responses and you naturally just want to see what or return what's appropriate for you. We also then just emit JSON as we want to consume that. And then we have the same construct we had in the previous sample where we add that to our FG response body. We also have our HTTP binding like we did previously. This is also surfaced by the OpenAPI definition. So also it's quite a simple example. We'll get into some of the patching and updates soon, while it is still busy thinking. Okay, so it's currently seeking some endpoints. It's running some searches for the Flowgear SDK usage, planning some stuff. You can also see if it has actually already made some changes. It's currently still thinking.
Too much planning.
Too much planning. Yeah, so the time it takes, it does vary. Sometimes it can be quite quick, but also the longer it takes, usually it is more accurate as well. And even the styling can be better if it takes a bit longer. We've had that it creates the perfect dashboard, so we'll see how it goes this time. What we can also do...
We'll cut it off at a timeout if it's taking too long.
Yeah, if it's taking too long, we'll just cut it off, and we can show you one of the pre-built ones we ran before. So I can show the other workflows we have as well for Salesforce, while this is still busy thinking. So that was the get leads. So what we'll do in subsequent calls is update the lead status. So what we have here, instead of just having a response body, we also have a request. So we want to actually patch the specific status. So whether a lead has been converted or whether they're still working on it. So we also have a sample that we provide here for the OpenAPI definition. Here we do a quick map to validate whether it is a valid status, and if it is not, we'll throw an error. So we don't want to attempt to update to an invalid status. We also map our requests, only the certain changes we want to make. Don't want to update the entire payload. Then we have our update lead. So this is specifically also just updating a lead in Salesforce, and then returning the response directly as is as well. So whether it was successful, whether it's failed, just also so that we can handle error messages as well. Also still has the same type of HTTP binding with a different method specified. Yeah, let's see if it's made any progress there. Okay, well, it's created some stuff. So it created a lead type file, it created the lead service. Now it's actually edited the app TSX. So this is our main component app. So now it's just planning some refinements. We can also go check in GitHub exactly what's been changed in the meantime. So here is our lead type that's been changed. or been added. So we have a specific lead record based on the workflow that it's backing. We also have the list of record items. And here we can see it also used the Salesforce leads endpoint as the OpenAPI definition provided. And in the app, it's probably going to be quite a bit. So we have our leads data, we have loading data, as well as error data. That's all been compiled now. We also have where it's been loaded. And then down here we can see Hello World's been replaced with actual Salesforce lead dashboard. We have some titles. We actually have a card and a grid. So yeah, it's actually looking good. We can probably already...
Anyway, let's see what's happening in the UI.
Yeah, I just wanted to say we can actually already see something happening. Yeah.
Oh, there we go.
So we already have some stuff happening. It did take a bit longer than it usually does, but it's actually, the styling is the best I've actually seen in all the iterations I've done. As we can see now, it created a nice dashboard. It includes the person for the lead. It adds status badges with some color coding. Even adds some icons specific to the person the lead is on.
Yeah.
And even some lead sources. So yeah, it's actually looking great.
There's a question about which agent to use. So you can use any agent. So I guess the top contenders would be Gemini, Claude, ChatGPT, which is Codex, and Copilot. I think people on our teams are all using different ones, and we like to keep our understanding of these current, because almost every month there's changes, and one will be slightly better for one scenario. But Codex has been consistently pretty good. It's probably our favorite at the moment. And I think one thing that we like about it is it's got a good way of balancing the fact that you didn't specify very well with giving you a reasonable result anyway. So for example, I think we just asked it to build a bunch of tiles for leads. We didn't say anything about the design, but the design it's come up with is quite reasonable. And either as part of your initial prompt or as a follow-up, you could refine it and say, actually, I want the tile to look this way, and move this to the right and change the font on this and so on. So kind of out the box, it allows you to provide a very rudimentary prompt, and the result is generally not aesthetically displeasing. But this is the great thing with vibe coding, is you don't need to know anything about coding. You don't need to know anything about React. This can get you from 0 to 1, and you can just continuously reprompt to make corrections. But by contrast, if you have a software background, this is a really good way to sort of make a start. And you might find that once you get into it and you want to sort of polish out some rough edges, it's more convenient for you to do that by hand, and obviously you're free to do that. But the kind of compression on the combination of being able to build the back end as workflows coupled with using AI to build the front end means you can get these built really quickly. And that just changes the way that you use these apps in the business. Whereas before it would have been a project that's got to go to a team who's got to pay for it, you've got to find budget for it. Suddenly you're able to do things at a fraction of the time, which means you can be much more responsive in getting these out, and they don't have to live forever. You don't have to plan for an app that's going to have a lifetime of 3 years. You can build something now because the cost is so low, and in a month you might scrap it because it was actually a bad idea, or you might improve it because it's been so useful. So it just gives you a lot of options because the cost to get this done is so much lower than it would have been pre-AI.
And actually now it finished, and in that time we actually also added another prompt to add a drop-down to update the lead status by calling a different workflow, and that's actually also been completed in that small amount of time. So now we can come back here and we can see we have our cards, and now we also have a drop-down with some status updates, statuses that we can now actually update. So we'll go do that. You can see that it actually did save it, and it actually refreshes and added some extra state. And yeah, very basic prompt there, just asked to add a drop down to update the status. And yeah, it's completed that. So last part of this use case, just going to quickly ask it to give us a small little chart, just a pie chart of leads by status. So we'll see how it manages that. We're not, as you can see as well, we're not giving it like tons of information of how we want to style it or how we want it to be structured. And that's the beauty of the iterative design. If you're not happy with it or you have better ideas, you can ask it and it will comply. So as we can also go back to some of these other workflows while it's busy, shouldn't take, I think, too long on this one. What we have is the status options. That was now what was used to actually allow for the options for the drop down. This was very basic. I believe we just have some configuration variables. In Flowgear, this is a construct to be able to persist variables, to persist it across like calls or invokes and be able to use it in different workflows. So we just put that straight into a formatter, and then after that, we actually just return that as our list of statuses. So quite basic, but yeah, you can just basically provide as much as you need to aid how it actually invokes that. So see, it's actually busy with stuff. I think it's still busy with styling, I'm hoping, because it is becoming quite large. So we can just switch over to our VS Code, see what it's busy with. Okay, so I can see it's still busy adding some new CSS, actually adding for the pie card that it's busy creating. So we can actually just keep an eye and see how it changes. Oh, it's already a bit better, already a bit smaller. So we can see it has some chart, it has the specific statuses as well as the percentage for each status. Colors maybe a bit close, but that is something you can prompt it to change and to update a bit. But yeah, not too bad. Now when we switch over back, it's finished working. It added the pie chart, driven by the Salesforce data. It aggregated the leads by status and mapped them to colors. It built like a SVG pie slicer, so actually used the ACG, which is quite interesting. And yeah, I ran the npm run dev to make sure everything was looking good.
So why don't we switch to pre-built for the other two scenarios, maybe just share the prompts.
Okay, yeah, so for the last two, we'll just switch over to pre-built applications, since it could take some time. So for our third use case, I'm just going to switch that over. We basically, for this, we have a ConnectWise service ticket triage. So basically just list a Kanban board of tickets, and also with the ability to actually go and update the statuses. So just going to switch over. The prompt I believe we used on this one was just to create a Kanban style board, grouping tickets by priority by calling the ConnectWise gets ticket workflow. So that was also in the Open API YAML. So if we switch back over, this is what was created with a run I did earlier. So we have our different lanes of priorities. We have the priority 1, priority 2, priority 3, and 4. And now we have a count of all our different tickets in here. What we also have is the ability to shift and to create or to update the priority as needed. We also have the ability to actually export some data. So that was the final part of the prompt, is to just use the same endpoint, but we added a export parameter to it. So that would actually go and generate an Excel report. So we can just click on that. And now we actually have an export of this data in Excel form. So I'm just going to load that up quickly to indicate what it returned. Yeah. So as we can see here, we have some summary, we have the actual contact name, some email address. So basically what you saw in the Kanban, we now have exported to Excel as well. So that was the third use case, and then now we can switch over to our final use case, which is what Dan mentioned before, which is our midway integration scenario, which is like a failed invoice Sage reconciliation. So basically what happens is you can have integration for some invoices. This example was Sage intact. We try and create an invoice, and for some reason it would actually go and fail. And then in Flowgear, we have a notion called key values, where you can actually go and store these failures. And here we actually expose and return these failures and allow a user to reconcile or update some info to actually now go and retry that data. So switching over here, we have our list of failed invoices. We have a few of them. We have some error messages, like the transaction amount exceeds the customer credit limit. So in this case, you can go and change it to whatever you need to be able to rerun that.
I think your customer's going to be happy with you about that.
Yeah, right. Big dip. Then you can go and save that, and after it's saved, it's going to refresh, and now you can also go and retry. So save is just updating the actual data for this invoice. Now retry is actually going to put it back into the queue to be reprocessed again. And as you see, it now completely disappeared from this list because it's now no longer a failed invoice for the time being. It's going to go be reprocessed, and if something fails again, it will come back here and the middleman can make adjustments as needed. So the prompts we added for this, I'm just going to copy this quickly over here. It was a four-way prompt where we asked it some iterations on a couple of things. So we asked, can you create a table with filters showing failed invoices and add a red highlight to rows with critical errors by calling the Sage Intacct get failed invoices workflow. Then after that, we asked to make the fields editable in line and update the request by calling the Sage Intacct update failed invoice workflow. Then we add a retry button on each row that calls the Sage Intacct set invoice to retry workflow. And then lastly, we asked to lock the invoice numbers, severity, the status, retries, and error message columns from being edited. Now note this is just for front end. Naturally, you want to also make these adjustments on the back end side. This is just for UI to already restrict users from making changes that way they couldn't anyway. And yes, that is our use cases for today. So I'm just going to go switch back to our slide and then just hand over to Dan.
Great, thanks Rick. So I hope that gave you a good flavor for what building these apps feels like. Certainly something we've had a lot of fun with, and we're super keen to hear the use cases that you'd like to apply it to. So to get started with this, we've got a full walkthrough over at help.flowgear.net. Just search for building apps. There's an article with that exact name. That'll walk you through the kind of basic setup steps, exactly as you've seen presented today. And then you can also take a look at the public GitHub repo Flowgear sample app. That's where your kind of initial boilerplate is going to be. And into that, we've already created the prompt for the agent, so there's nothing you need to tweak there. You literally need to put in your tenant key, your site key into that environment file that we showed you. Bring in your open API defs, and then you're good to prompt from there. And then finally, our team would love to personally help you out with this as well. So if you do want to get some help as you start to build out, then feel free to use the help button to create a ticket with us over in the console. So great, thank you very much for joining us, and we'll see you again soon. Cheers.